Final Year Project 1, Project Proposal Presentation. Title of project is Design of Gravity Type Fish Grader for LKIM Deployment.
Hi, Assalamualaikum and a very good day to all the panels. My name is Nurul Syamilah Aqilah binti Omar from School of Mechanical Engineering. Today, I would like to present about my final year project proposal and my supervisor is IR Dr. Noriah Yusoff. My presentation slide will cover project summary, introduction of the study, literature review, problem statement and objective, scope and limitation, methodology that used for this project, preliminary result and reference. First, we will go to the summary of the project. Fish grading is a management strategy that includes dividing fish into groups of comparable individual size. The goals of this research is to investigate and determine the best slope for fish to slide down and the gravity sorting platform. The length and mass of fish are used to calculate the thickness of the fish and determine the distance between the roller, and based on the parameter setting they obtained, gravity type fish grader was designed using SolidWorks software. Next, we will move to the introduction of the study. Landing of fish jetty complex are used as landing point for fish product from fishing vessel, and they typically including a landing area, cleaning area, sorting area, selling area, and storage. The flow of the procedure at the jetty is starting from the shipping area for the unloading process. Then fish will be landing and sorting at the fish sorting area. After that, weighing area is the place where pricing be deciding among the fishermen and perai and record the payment. Packing the fish into the isolation box is done after that, and continue with loading and distribution process. Finally, lorry will be at the packing area for pickup process.
As shown is the situation of the landing area at Fish Landing Complex LKIM Kuantan Pahang. As you can see, the process at landing area is start from unloading process, then move to the sorting process, next weighing process, and proceed to the packaging process to insulation box. Next picture shows the installation area that organized according to its color for the distribution.
Lembaga Kemajuan Ikan Malaysia LKIM Kuantan is one of the East Coast largest landing area, and annual trend of fish landing was collected from that location. As shown in the table and the graph, Kuantan's yearly landing pattern demonstrates an increase in fish landing starting from 2013 to 2018. Data of fish landing also shows an increment for the monthly and daily landing. LKIM has continued to rely on the human labor to finish the sorting and grading over the years. Traditional manual sorting relies mostly on the master of the sorting labor by evaluating the size and weight of the fish based on their own eyes and hand feeling. It is clear that a competent fish landing jetty sorting system will ensure that the handling process runs well and contribute to Malaysian fisheries growth. One of the sorting techniques that effectively grade fish according to their size is the gravity method. It is a gravity conveyor platform that is neither powered or driven by an external power. This conveyor runs on a vertical plane and have a slope to help in the movement of the fish. The size of the fish to be placed in each class is determined by the distance between the grading rollers. For the next part, I will continue with literature review. Gravity conveyor are one of the most adaptable and cost-effective way to move product with the least amount of work and price. A gravity conveyor can swiftly move huge number of objects in practically any direction. The use of condition factor is based on the assumption that fish in a better condition have a complete bodies and are hence heavier at the given length. Gravity roller conveyor, also known as a non-power roller conveyor, are appropriate for transporting most units load with a solid, flat bottom surface. A sequence of roller, the frame on which the roller are mounted, and the support on which the frame is supported make up an unpowered roller conveyor. Based on the conveyor platform study of the researcher, UK and Unde Sapota Fruit Grader. To increase fruit grading productivity while saving time and labor, a Sapota Fruit Grader based on diverging roller type principle was created and developed. Similarly, for the highest efficiency of 89.5%, combination of a roller speed, inclination, and roller gap was discovered to be 223 RPM, 4.5 degree, and 38 mm to 64 mm. By Gayatri for manual onion grader, experiments were conducted on the 3 different slopes and each with 3 different feed gate, opening length, and 2 different swing orientation. The characteristics were at a 4 degree slope. By Asid El-Shahad Adallah of the researching washing machine with raceway grading to provide a homogeneous distribution of a water inside the graders, water column. The washing machine featured 4 aerated water inlet via 4 ventures and 4 extra inlet via ventures for the grader canal. 5 degree and 7 degree canal inclination level was provided. By a L-shaped cylindrical grading, all of the olive fruit kind study had higher grading efficiency when the length and tilt angle of the grading mechanism were increased. The cylindrical has a length of 600 mm and rotational speed of 8 rpm and a tilt angle is 0.0175 radius. By a same researchers, for a belt grading, the machine is setting for belt speed, grading unit slope, radian and olive feeding rate. The greatest grading effectiveness of the olive and under consideration was between 91% and 93%. Feed rate of 50 gram per second, were a belt speed of 0.11 meter per second, and tilt angle is 35 degree were the parameters. By Liza and Kadir, size grading, the size grade determined by one dimension, the minimum distance between 2 parallel bars. For 2 dimension, the distance between the side of the square hole and diameter of a circular hole. For the 3 linear dimension or its mass, inclination is fixed at 10 degree.
This part, I will explain about the problem statement and objective of this project.
Fish landing jetty complex efficiency is linked to output and performance. Malaysian fish landing jetty complex design and facilities are out to date, especially in terms of fish grading. Fish grading is now done by hand, which takes more longer, and feeding is time-consuming and tiring activity. The use of a sorting conveyor has been found to increase efficiency by lowering labor costs and reducing fish damage from human handling. The main objective of this project is to determine the conveyor platform design parameter setting based on the specific fish. Next is to analyze the optimal slope for fish sorting conveyor, and last but not least is to propose a gravity conveyor platform of the fish sorting activity.
After that, I will explain about the scope and limitation of this project.
The goal and scope of this project is to analyze and suggest the optimal gravity flow for a conveyor platform used to convey fish down with the best gradient. Information of the fish size will be used to determine the parameter setting of the distance between the rollers. The fish grader design in a SolidWorks. However, this project has a few limitations because of the limited time and resources, which are only one type of fish is used for the study of fish sorting. Then is due to the COVID-19 situation, the research conducted by referring to researchers on the internet.
Methodology is the method I used to complete this project proposal, and I will present to you after this.
This project is divided into 3 phases: research study, model setting, and proposal phase. The methods that have been altered and implemented for this project are based on the survey of the literature. For phase 1, there have been a research into various fish sorting methods, and there are several different methods of grading and sorting fish that are commonly used, including human eyes inspection and estimation, visual comparison against a fixed roller grader use, optical based sensory system, and a computer vision based system. A horse mackerel was chosen for this study, and table shows the grading data of fish size which are size S, M and L with their approximate length and weight. Phase 2 is a model setting to determine the distance between the roller and slope of the grading platform. The distance between the roller is determined using equation Fulton's condition factor. The thickness or thinness of a fish in relation to its length is referred to it as a condition. A fish with a high condition factor is considered to be big. A skinner fish may be treated for a smaller fish. To obtain the thickness of the fish, length-weight relationship is applied in the next equation. Slope of the conveyor platform was designed based on the cabin plan grading machine. It is designed to transport the product without causing the damage. The machine dimension is used to determine the optimal slope of the platform using the trigonometric function. The last phase is to propose the platform design by using SolidWorks software.
Next is preliminary result they obtained from this study.
From the research and data collection that had been conducted, the platform of the conveyor that categorized the fish shown in the preliminary result. Fish is categorized into three depending on its thickness, which are in the range of 0.294 cm to 0.649 cm. The table indicates the condition factor of the fish and also reveals how thick a fish is in relation to its length. In general, the machine will sort or divide the fish into three categories by sliding down the conveyor platform at an angle of 13.12. Next is the figure of 3D design that developed in the SolidWorks software and its dimension based on the parameter setting that were calculated. To segregate the fish, the newly captured fish will pass through the space between the roller that has been adjusted according to its thickness of fish, which are size S is 3 mm, size M is 5 mm, and size L is 7 mm.
Last but not least, this is the list of references that I refer during conduct this research.
Thank you for your time and thank you for listening. If any question, please feel free to contact me by phone or email.